Space is an endless ocean of silent, waiting mysteries. We are about to dive deep into 30 terrifying facts about the cosmos, each one designed to shatter your sense of safety and challenge everything you think you know about reality. By the end, you will see the universe not as a beautiful tapestry of stars, but as a place of profound and unsettling truths. What unseen force is pulling our entire galaxy toward an invisible point in the void? What cosmic catastrophe could erase life on Earth without a moment's warning? The answers are more frightening than fiction. Are you ready to confront the genuine terrors hidden in the dark? The first terrifying truth begins not with a bang, but with an absence. The vacuum of space is not just empty. It is a silent, ravenous force that would dismantle your body in a matter of seconds. This is not the dramatic explosion you see in movies. It is a far more intimate and gruesome end. In the total absence of atmospheric pressure, the fluids in your body would begin to vaporize instantly. Your saliva would boil on your tongue. The water in your skin and soft tissues would turn to gas, causing your body to swell to nearly twice its normal size, a horrifying condition called ebullism. Your lungs, filled with air, would collapse violently as the pressure difference pulls the breath from them. You would not freeze solid immediately, as the vacuum is a terrible insulator. In fact, you would lose consciousness from lack of oxygen in about 15 seconds, but the physical unraveling would continue. Your blood, no longer contained by normal pressure, would literally begin to boil in your veins. All of this happens in utter silence. There is no sound in the void to carry your final moments. The cosmic horror lies in this swift, efficient, and eerily quiet destruction. A reminder that our bodies are fragile vessels designed for a single, delicate bubble of air and pressure we call home. That silent, ravenous vacuum is a personal terror, but the cosmos holds threats on a scale so vast they defy human comprehension. Our galaxy, the Milky Way, is not drifting aimlessly through the void. It is being pulled, along with every galaxy in our local neighborhood, toward a specific point in the darkness. Astronomers call this the Great Attractor. It is a gravitational anomaly of staggering power, located some 220 million light-years away in the direction of the constellations Centaurus and Hydra. Think about that for a moment. An entire cluster of galaxies, including our own, is being reeled in by something we cannot even see properly. The core of this monstrous region is hidden from our view, obscured by the thick band of stars, gas, and dust that makes up the plane of our own Milky Way. It is a hidden monster, its true face masked by the very galaxy we call home. This creates a profoundly unsettling reality. Our entire cosmic destiny, the ultimate path of our galaxy over billions of years, is being dictated by a force whose source remains shrouded in mystery. We are like passengers on a vast ship, feeling the pull of a powerful current, yet unable to see the waterfall that lies ahead. We can measure the pull, we can chart our course toward it, but we cannot see what is doing the pulling. This invisible dictator of motion reminds us that even on the grandest scales, the universe operates with secrets it is not yet ready to reveal. While the Great Attractor pulls our galaxy toward an unseen future, there are cosmic wanderers that travel with no destination at all. They are rogue planets, entire worlds violently ejected from their home solar systems during the chaotic gravitational dances of their youth. Cast out, they now drift through the interstellar void completely alone. These are not planets as we know them. They have no sun. Their skies are a permanent, starless black. Any warmth they once held has long since bled away into the absolute cold of space, leaving surfaces frozen to temperatures near absolute zero. Imagine a world of eternal midnight, where the only light comes from the distant, unmoving pinpricks of galaxies far away. It is a profound and chilling form of solitude, an entire Earth-sized object on a billion-year journey through nothingness. But the true terror is not their loneliness, it is their potential for silent, unseen invasion. Our solar system is not a sealed fortress. The space between the stars is filled with these dark nomads, and astronomers estimate there could be billions of them in the Milky Way alone. One could be passing through our own solar system right now, invisible to our telescopes because it emits no light of its own and reflects no starlight. If such a planet, even a small one, ventured too close, its gravity could act like a cosmic cue ball. It could nudge asteroids from the stable belt, sending them on a collision course with Earth. It could destabilize the delicate orbital dance of the planets themselves, triggering a chain reaction of chaos. The most frightening part is we might not see it coming until it was already too late, a ghost from the dark rewriting our fate without a sound. These dark nomads are a silent threat, but the universe also wields weapons of unimaginable, instant firepower. Gamma-ray bursts are the single most powerful explosions known to exist, second only to the Big Bang itself. They are cosmic death beams, born from the catastrophic collapse of massive stars or the violent mergers of neutron stars. In a matter of seconds, a single burst can release more energy than our Sun will emit over its entire 10 billion-year lifetime. All of that apocalyptic force is focused into two narrow, opposing jets of pure gamma radiation, screaming across the cosmos at the speed of light. Now picture one of those jets by pure cosmic chance pointed directly at our solar system. The event would begin without warning. A satellite might detect a sudden, overwhelming spike of energy from a distant galaxy. Moments later, the beam itself would arrive. It would not hit the ground, but it would not need to. The real devastation would happen high above us in the thin veil that protects all life on Earth. In a flash, the gamma radiation would rip through our upper atmosphere, violently breaking apart the molecules of our ozone layer. In less than a minute, a shield that took eons to build could be utterly stripped away. The aftermath is where the true, slow-motion horror unfolds. With our protective ozone gone, the planet would be bathed in the sun's full, lethal intensity of ultraviolet radiation. Ecosystems would collapse, phytoplankton, the base of the ocean's food chain, would die off. Land plants would wither. Animals, including humans, would suffer catastrophic rates of mutation, cancer, and blindness. It would trigger a global mass extinction event, not from impact or fire, but from an invisible bath of poison light. The most terrifying aspect is the sheer randomness of it. There is no defense, no prediction, and no recourse. A star dying billions of light years away could, by the simple alignment of its final scream, end life on Earth before we even knew it had happened. That apocalyptic beam of light from a dying star is a random cosmic bullet, but our own star holds a far more certain and personal doom. The Sun, the giver of all life on our planet, will one day become its destroyer. This is not a theory or a possibility. It is the guaranteed fate of our solar system, written into the fundamental laws of physics. In about 5 billion years, the Sun will exhaust the hydrogen fuel in its core. As it begins to burn helium instead, it will undergo a violent transformation, swelling into a monstrous red giant star. Its outer layers will expand outward, cool to a dull red, and engulf the inner planets. Mercury and Venus will be the first to vanish, consumed without a trace. Then, the expanding edge of this dying star will reach Earth. The final days of our world will be a spectacle of absolute horror. Long before the Sun's photosphere touches the surface, its increasing radiation will have long since boiled away our oceans, turning them into a thick, scorching steam atmosphere. The continents will bake and crack, their rocks melting into glowing rivers of magma. The sky itself will be filled with the colossal, bloated disk of the red sun, swallowing the entire horizon. And then, if Earth is not flung into a wider orbit by the Sun's changing mass, our planet will simply be swallowed whole. It will spiral into the sun's outer layers, vaporizing in a final, silent flash, its atoms scattered into the star's atmosphere. The existential terror here is not in the timing, but in the certainty. A clock is ticking on our entire world, a countdown set at the moment of the solar system's birth. Every mountain, every ocean, every memory of humanity is destined to be erased by the very star that made it all possible. It is the ultimate cosmic betrayal, a reminder that even the most permanent fixtures in our sky are merely temporary stages in a universe of constant, violent change. This ultimate betrayal by our own sun reveals a deeper, more fundamental terror about the cosmos itself. Everything we can see, everything we are made of, is nothing more than a cosmic afterthought. The stars, the planets, the very atoms in your body, all of this normal matter accounts for less than 5% of the entire universe. The rest, the overwhelming 95%, is made of things we cannot see, touch, or even begin to comprehend. We are living in a ghost house, a universe where the real substance and the real forces are invisible phantoms. The first phantom is dark matter. We know it exists because we can see its gravitational grip on the things we can see. Galaxies spin so fast that the visible stars and gas alone should be torn apart and flung into the void, but they are not. Something with immense mass is holding them together. A vast, unseen halo of dark matter that acts as a gravitational skeleton for every galaxy. It is everywhere, passing through you right now in silent, ghostly streams, yet it does not interact with light or normal matter in any way we can directly detect. It is a shadow universe woven through our own. The second and far more unsettling phantom is dark energy. This is not matter at all, but a property of empty space itself, a repulsive force causing the expansion of the universe to accelerate. Think of it as anti-gravity, a pressure inherent to the vacuum that is relentlessly pushing galaxies apart. The terror here is existential. We have named these things dark matter and dark energy, but those are just labels for our ignorance. We do not know what they are. We only know they dominate the cosmos, dictating its fate on the grandest scales. Our entire reality, our history, our future, is a tiny island of visible light floating in an endless dark sea of unknown forces. We are like characters in a play, believing we understand the story, only to realize the stage, the curtains, and the very theater are made of something we cannot perceive, controlled by rules we have not yet written. These invisible phantoms of dark matter and dark energy shape the cosmos from the shadows, but there are other shadows with a far more tangible and immediate hunger. Our galaxy is home to millions of wandering black holes. We are not talking about the colossal supermassive black holes that anchor the centers of galaxies, but their smaller, more numerous cousins, stellar mass black holes. Each one is the corpse of a massive star that collapsed under its own weight, crushing itself into a point of infinite density called a singularity. They are the ultimate ghosts, completely invisible, detectable only by the way their gravity bends the light of distant stars or pulls gas from a companion. Astronomers estimate the Milky Way could be infested with as many as 100 million of these dark remnants, all drifting silently through the spiral arms. Now consider the chilling possibility of one passing relatively close to our solar system. It would not need to be on a direct collision course to spell our doom. Its gravity is so intense that it warps the very fabric of space-time around it. As it moved through our neighborhood, that gravitational distortion would act like a cosmic bulldozer plowing through a carefully arranged sandcastle. The delicate, stable orbits of the planets, perfected over 4.6 billion years, would be violently disrupted. Earth could be gently nudged or violently yanked onto a new path. We could be flung inward toward a scorching death near the sun, or more terrifyingly, hurled outward into the frozen, eternal night of interstellar space. Our planet would become a rogue world in an instant, its atmosphere freezing into a blanket of ice, all life extinguished as we are cast adrift into the silent dark. The most unsettling part is we might not see it coming until the stars in our night sky began to subtly, irrevocably shift from their ancient positions. The invisible forces that could fling our planet into the dark are governed by laws that twist reality itself. Einstein's theory of relativity reveals a terrifying truth about our universe. Time is not a constant river flowing the same for everyone. It is a personal experience warped by speed and gravity. The faster you move through space, the slower you move through time relative to someone who is stationary. This effect, called time dilation, is not science fiction. It is a measurable, proven fact of our cosmos. For an astronaut embarking on a journey at a significant fraction of the speed of light, this becomes a chilling, one-way trip into the future. Imagine a mission to a nearby star system, a voyage that takes the crew, from their perspective, just 10 years. Due to the incredible speeds required, time back on Earth would have marched forward at a vastly different pace. When those astronauts return, they would have aged only a decade, but they would step out onto an Earth where 50 or 100 or even more years had passed. Everyone they ever knew, their family, their friends, their children, would be gone or aged beyond recognition. They would be strangers in their own world, relics from a past era, unable to recognize the society or the technology around them. The psychological toll is almost too profound to grasp. You would have the memories of a life that, to everyone else, is ancient history. Your entire frame of reference, your culture, your connections would be fossils. This is the ultimate, lonely consequence of relativity. To travel to the stars is to sever your bond with the human timeline. You would become a ghost from the past, haunting a future you can never truly call home. That one-way trip into the future is a lonely fate, but at least the traveler would be moving through a universe of stars and galaxies. What if you journeyed into a region of space where there is almost nothing at all? Lying some 700 million light-years from Earth is a place of profound emptiness known as the Boötes Void. Astronomers sometimes call it the Great Nothing. This is not a metaphor. It is a spherical region of space roughly 330 million light-years in diameter, a volume so colossal it could contain thousands of galaxies like our own Milky Way. Yet inside this unimaginable vastness, surveys have found only a handful of lonely galaxies, perhaps 60 or so, drifting in the dark. The rest is an almost perfect, chilling vacuum. To understand the scale of this emptiness, picture our own local neighborhood. If you were to place the Milky Way at the center of the Boötes Void and look out in every direction, you would see nothing but an endless, starless black for hundreds of millions of light years. A spaceship traveling at light speed would journey for millions of years without encountering a single star, a single source of light, or a single world. The cosmic background radiation, the faint afterglow of the Big Bang, would be the only illumination, a uniform, cold glow in every direction. This void challenges our most basic assumption about the universe, that it is a roughly uniform soup of galaxies. Instead, it reveals a cosmos with a terrifying Swiss cheese structure, where immense bubbles of nothingness exist alongside the great walls and filaments of galaxies. The Boötes Void is a monument to absence, a reminder that the universe is not just filled with wonders, but with incomprehensible stretches of pure, empty dark. The profound emptiness of the Boötes Void is a cosmic desert, but the seemingly empty stretches of space between stars are not truly empty at all. They are filled with an invisible, relentless, and deadly rain. This is the constant, high-energy barrage of cosmic radiation. Every second, trillions of subatomic particles, accelerated to nearly the speed of light by distant supernova and black holes, are screaming through the void. Here on Earth, we are blissfully unaware of this radioactive storm. Our planet's magnetic field acts as a powerful shield, deflecting most of these charged particles toward the poles where they create the beautiful auroras. Our thick atmosphere then acts as a final protective blanket, absorbing what little gets through, but step outside that bubble and you are exposed. For astronauts, this is a daily, terrifying reality. Inside a spacecraft or the International Space Station, they receive a dose of radiation equivalent to about one chest X-ray every 5 days. On a journey to Mars, that exposure would skyrocket, with estimates suggesting a trip could expose a crew to radiation levels that increase their lifetime risk of fatal cancer by around 3%. The damage is not just statistical. These high-energy particles can slice directly through human cells, shredding DNA and causing mutations that lead to cancer and other diseases. But there is an even more immediate and chilling effect. Scientists studying rodents exposed to simulated cosmic rays have observed something they call space brain. The animals showed significant signs of cognitive impairment, including memory loss, anxiety, and an inability to perform tasks they had previously learned. The radiation was literally altering the structure and function of their brains. Imagine embarking on a 2-year mission to Mars, only to find your focus dissolving, your memory failing, and your decision-making clouded by a fog you cannot shake. And then there are the sudden, violent outbursts from our own sun. A solar flare or coronal mass ejection can unleash a wave of radiation so intense it can penetrate spacecraft hulls, delivering a lethal dose in a matter of hours. During such an event, astronauts would have mere minutes to retreat to a shielded compartment, listening to the ping of high-energy particles striking their vessel like a deadly hail. Space is not a serene vacuum. It is a radioactive ocean, and we are fragile sailors in paper boats, utterly dependent on thin layers of metal and clever engineering to survive a storm that never truly ends. Even that radioactive storm is a constant in our cosmic environment, but some of the most fundamental constants we rely on are not permanent at all. Our own moon is in the slow, steady process of leaving us. With each passing year, it drifts about 1.5 inches farther out into space. This tiny distance seems insignificant, a change measured in the width of a thumb over a human lifetime. But across the vast expanse of geological time, this gentle retreat is rewriting the very rhythm of our world. The mechanism is the ocean tides. The moon's gravity pulls on our oceans, creating the familiar bulge of water that follows it around the planet. Earth, however, is spinning rapidly beneath this tidal bulge. This creates a kind of gravitational friction. The bulge actually pulls slightly ahead of the moon, and that pull, in turn, tugs on the moon, giving it a tiny energy boost that pushes it into a higher, slower orbit. The energy for that boost comes from Earth's own rotation. Our planet's spin is gradually slowing down. Billions of years ago, a day on Earth was only about 6 hours long. The moon was much closer, looming enormous in a sky that whipped by in a blur. As the moon drifted outward, our days grew longer. This slow-motion divorce will continue. In about 50 billion years, if our sun had not already destroyed both worlds, Earth's rotation would finally slow to match the moon's orbital period. A single day would last as long as a month does now. The moon would hang motionless in the sky over one hemisphere, a permanent, silent fixture, while the other side of Earth would never see it again. The tides, driven by that gravitational dance, would become a faint memory. Our oceans would grow still, their vital churning and mixing greatly reduced, altering global climates and the chemistry of life itself. This is not a violent catastrophe, but a profound, inexorable change. The most intimate relationship in our sky, the partnership that stabilizes our planet's tilt and governs the pulse of our seas, is quietly unraveling. We are living in a transient, golden era of perfect lunar eclipses and powerful tides, a temporary balance in a solar system that is constantly, subtly falling apart. That slow-motion divorce from our moon reveals a solar system in subtle flux. But what if our cosmic backyard holds a secret far more massive and immediate? Beyond the orbit of Neptune, in the frigid, sunless reaches of our solar system, astronomers are hunting a ghost. They call it Planet 9, a hypothetical world with a mass up to 10 times that of Earth, tracing a vast, elliptical orbit so distant it takes up to 20,000 years to complete a single journey around the Sun. We have never seen it directly. Its existence is inferred from a strange gravitational whisper, a pattern of disturbance in the darkness. Far past Pluto, in a region called the Kuiper Belt, there are small, icy objects with orbits that are clustered and tilted in a way that defies easy explanation. They swing around the Sun on paths that seem oddly aligned, as if they are all being shepherded by the same invisible hand. The most plausible explanation for this celestial choreography is the gentle, persistent tug of a hidden giant. This would not be a planet like the others. If it exists, Planet 9 is a frozen behemoth, a world of rock and ice so far from the Sun that its surface temperature is near absolute zero. Its sky would be a permanent starry night, with our own Sun appearing as nothing more than an exceptionally bright star, casting no meaningful warmth. It is a chilling thought. We have mapped our neighborhood for centuries, yet we may have missed an entire world larger than Earth, silently tracing its monstrous orbit in the perpetual dark. This potential hidden giant forces a humbling realization. Our solar system is not a fully known and charted territory. There are still shadows large enough to hide planets and forces at play we have only begun to sense. The search for Planet 9 is a modern-day cosmic detective story where the clues are not footprints or fingerprints, but the subtle wobbles of tiny, frozen worlds billions of miles away, all pointing toward a master we cannot yet see. Even if our solar system holds a hidden giant, its fate is ultimately tied to a far grander and more inescapable conclusion. The universe itself is running down, and its final state is not fire but ice. This ultimate end is known as the heat death, a concept rooted in the relentless increase of entropy. Entropy is simply a measure of disorder in a closed system, and the universe is the ultimate closed system. Everything tends from order toward chaos, from concentrated energy toward a bland, uniform spread. Right now, the cosmos is a place of dramatic contrast. We have blazing stars next to the cold void, immense gravity wells next to empty space. These differences in temperature and density are what drive all action. They allow stars to burn, planets to form, and life to think. But entropy is slowly erasing these contrasts. Over trillions upon trillions of years, every star will eventually exhaust its nuclear fuel. The last red dwarfs, the smallest and longest-lived stars, will finally flicker out. No new stars will be born, as the great clouds of gas and dust needed to form them will have been consumed or scattered too thin. The galaxies will fade from brilliant spirals into dark graveyards of dead stars, cold planets, and the silent, spinning corpses of black holes. But even the black holes are not eternal. Through a bizarre quantum process known as Hawking radiation, they will slowly evaporate, releasing their final whispers of energy over timescales so vast they make the current age of the universe seem like a single heartbeat. And after the last black hole has dissipated, the universe will enter its final, permanent phase. There will be no more hot spots or cold spots. Every corner of the cosmos will reach the same uniform temperature, just a fraction of a degree above absolute zero. This is the true terror of the heat death. With no temperature differences, no energy gradients, there can be no work done. No motion is possible, no chemical reactions can occur. Every atom will be essentially frozen in place, separated by unimaginable distances in an expanding darkness. Time itself may become meaningless, as with no change, there is no way to mark its passage. It is not an explosion or a collapse, but a slow, silent fading into a state of perfect, eternal equilibrium. All stories will have been told, all lights extinguished, all possibilities exhausted. The universe will be a still and silent tomb, not just for life, but for the very concept of happening itself. The silent, eternal freeze of the heat death is a distant abstraction, but the solar system holds dangers that are immediate, random, and utterly devastating. Asteroids do not announce their arrival. On a clear morning in February 2013, over the Russian city of Chelyabinsk, the sky was torn apart by a fireball brighter than the sun. This was not a large asteroid by cosmic standards, merely a rock about 60 feet across. It entered Earth's atmosphere at over 40,000 miles per hour, and the immense pressure of its passage caused it to explode in a violent airburst nearly 15 miles above the ground. The shockwave that followed shattered windows across the city, injuring over 1,500 people with flying glass. The entire event, from the blinding flash to the arrival of the destructive blast, took less than a minute. The most chilling fact is that no one saw it coming. It approached from the direction of the sun, completely hidden in the glare, a perfect cosmic ambush. The Chelyabinsk meteor is a stark reminder that our planet exists in a cosmic shooting gallery. It was a tiny rock, yet it released energy equivalent to about 30 times the power of the atomic bomb dropped on Hiroshima. Now consider the scale of the object that struck Earth 66 million years ago, the one that ended the reign of the dinosaurs. That asteroid was an estimated 6 miles wide. Its impact instantaneously excavated a crater over 100 miles across, triggered global firestorms, and flung enough debris into the upper atmosphere to plunge the planet into a years-long impact winter, collapsing ecosystems worldwide. An event of that magnitude today would not just be a natural disaster, it would be an instantaneous end to human civilization as we know it. The terror lies in the combination of sheer destructive power and our current glaring vulnerability. While major space agencies diligently track larger, civilization-ending asteroids, there are millions of smaller, city-killer-sized objects in near-Earth space that remain uncatalogued and untracked. They are too small and too dark to easily spot with our current telescopes, yet they are more than capable of unleashing localized or even continental devastation. Our planet's history is written in impact craters, a record of random, violent encounters with space rocks. The next chapter in that history could be written tomorrow, next year, or in a century, and we might only have the time it takes for a shadow to cross the sun to realize our fate is already sealed. Even the asteroids we can track are governed by laws we believe we understand, but at the very edge of our own solar system, those laws seem to falter. The Pioneer anomaly is a haunting chapter in the history of space exploration, a small but persistent whisper that something was fundamentally wrong with our picture of reality. In the 1970s, NASA launched the twin Pioneer 10 and Pioneer 11 probes on grand tours of the outer planets before they embarked on eternal journeys into interstellar space. For decades, scientists meticulously tracked their positions using the deep space network of radio antennas. As the probes drifted beyond Pluto, a disturbing pattern emerged. Both spacecraft were slowing down slightly more than all the known forces of gravity could account for. It was a minuscule deceleration, equivalent to a gentle pressure about 10 billion times weaker than Earth's gravity, but it was there and it was consistent. This tiny discrepancy sent a tremor through the world of physics. Had we discovered a new force? Was the pull of gravity itself behaving differently in the vast, sunless reaches at the edge of our system? For years, the anomaly fueled theories of modified gravity, unseen dark matter halos, or even leaks into other dimensions. The idea was terrifying in its implications. Our most trusted equations, the ones we use to navigate probes across billions of miles, might be incomplete. The cosmos might have a hidden rulebook for its darkest, most distant frontiers. Eventually, after a monumental effort, the most likely culprit was identified, an extremely subtle and uneven push from the probes themselves. The heat radiating from their nuclear power sources and onboard electronics was bouncing off the spacecraft structure, creating a tiny but constant thrust that perfectly explained the slowing. The mystery was largely solved. Yet, the unease it generated lingers like a ghost. For over a decade, the smartest minds on the planet seriously entertained the possibility that an unknown force was tugging at our machines in the void. It revealed how fragile our confidence can be, how a single, persistent day to point at the frontier can threaten to unravel our entire understanding of the cosmos. The Pioneer anomaly stands as a monument to a profound and unsettling truth. We send our robotic ambassadors into the dark, and sometimes the dark whispers back with questions we are not prepared to answer. That unsettling whisper from the Pioneer probes fades into a far louder, more profound silence. With hundreds of billions of stars in our galaxy alone, and many of those stars hosting planets in the habitable zone, the universe should be teeming with life. The numbers are overwhelmingly in favor of it. So, where is everybody? This is the core of the Fermi paradox, a question that transforms the vastness of space from a promise into a terrifying riddle. If intelligent life is common, we should see evidence everywhere: radio signals crisscrossing the galaxy, vast engineering projects rearranging stars, or at the very least, the faint hum of a million different civilizations. Instead, we hear nothing but cosmic static. The silence is deafening, and it suggests something is terribly wrong. One of the most chilling explanations is the concept of the Great Filter. This idea proposes that there is a series of immense, improbable hurdles any life form must overcome to reach the stars, and at least one of these hurdles is so difficult that it stops virtually every civilization in its tracks. The terrifying uncertainty is whether we have already passed this filter, or if it still lies ahead of us. If we are past it, if the leap from simple chemistry to complex, intelligent life is the universe's rarest fluke, then we are cosmically lonely but safe. We won the lottery of existence against impossible odds. The far more frightening possibility is that the Great Filter is still in our future. It could be the inherent self-destruction that comes with advanced technology, perhaps through nuclear war, engineered pandemics, or runaway artificial intelligence. It could be that any civilization that becomes detectable inevitably attracts the attention of something predatory. Or it could be a natural, periodic cosmic catastrophe, like the gamma-ray bursts we discussed, that sterilizes galaxies on a schedule we have not yet discerned. The silence, then, is not a sign of emptiness but a graveyard marker. Every promising world we see through our telescopes may hold the fossilized remains of civilizations that reached our level, looked up at the stars with hope, and then were abruptly, permanently silenced. Our own radio signals are only now beginning to leak into the galaxy. In the context of the Great Filter, every new technology we master, every signal we send, could be us unknowingly approaching a cliff that countless others have already fallen over. The paradox forces us to confront a brutal choice. Are we the first and only, or are we simply the next in a long, silent line of failures? Our fragile technological civilization hangs by a thread, and that thread is woven from copper and silicon. The greatest immediate threat to our way of life does not come from asteroids or aliens, but from our own star. A massive coronal mass ejection is a solar storm of almost unimaginable power. It is an eruption on the Sun's surface that blasts billions of tons of magnetized plasma directly into space at millions of miles per hour. If one of these eruptions is aimed at Earth, the consequences would be apocalyptic, not through fire and impact, but through silent, invisible electromagnetic force. When that cloud of charged particles slams into our planet's magnetic field, it creates violent fluctuations. These fluctuations induce powerful electrical currents in the ground itself, currents that seek the path of least resistance. That path is our global power grid, a sprawling web of high-voltage transmission lines and substations. The grid was never designed to handle this kind of direct planetary-scale electrical assault. The induced currents would overload transformers, the massive, expensive, and difficult-to-replace hearts of the electrical system. They would not just trip breakers, they would melt, explode, and burn out in a cascade of failures. The result would be a global blackout, but not one that lasts for a few hours or days. Experts estimate a direct hit from a Carrington-level event could plunge entire continents into darkness for months or even years. The time to rebuild would be measured not in weeks but in seasons, because we do not keep warehouses full of city-sized transformers. Each one is a custom-built, multi-ton piece of engineering that takes over a year to manufacture. And without power, the factories that make them would be silent. This is not speculation. We have seen a preview. In 1859, the Carrington event, a solar superstorm, struck Earth. The world was barely electrified then, but the induced currents were so strong they set telegraph papers on fire and allowed operators to send messages with the batteries disconnected. Today, that same storm would be a civilization-ending event. It would collapse everything that depends on the grid: water treatment and distribution, refrigeration for food and medicine, fuel pipelines, financial networks, and global communications. Society would be thrust back into a pre-industrial age overnight, but with a population of billions utterly unprepared to survive in it. The sun, the giver of life, holds the power to end our modern world with a single, silent blast of magnetized wind. That profound and unsettling silence of the cosmos was broken just once by a ghost. In the summer of 1977, a radio telescope at Ohio State University, known as the Big Ear, was methodically scanning the sky for signs of intelligent life. On the night of August 15th, the telescope's computer printed out a string of numbers and letters representing the signal strength it was receiving. A few days later, a volunteer astronomer named Jerry Amon was reviewing the long paper printout when his eyes locked onto a sequence that made his blood run cold. There, circled in red pen, was the alphanumeric code 6EQUJ5. It represented a narrowband radio signal, 72 seconds long, that rose and fell in intensity exactly as a signal from a fixed point in space would, as Earth's rotation carried the telescope's beam past it. It was coming from the direction of the constellation Sagittarius. In the margin, Amon scrawled the now legendary reaction: "Wow, this was not cosmic static or a known natural phenomenon." It was precisely the kind of signal the project was designed to find: a concentrated burst of energy on a specific frequency that nature does not typically produce. It screamed of artificial origin. The chilling part is what happened next, or rather, what did not happen. Despite decades of repeated, desperate searches targeting that same patch of sky, the signal has never been heard again. It was a one-time cosmic hello, a whisper that crossed the interstellar dark, tapped us on the shoulder, and then vanished forever. The implications are haunting. Was it a message sent just once by a civilization that has since fallen silent? Was it a malfunctioning beacon that briefly flickered on, pointed in our direction by pure chance before dying? Or perhaps it was something even stranger, like the reflection of a human-made signal off a piece of space debris, creating a perfect, cruel echo, the wow. Signal stands as the most compelling and most frustrating piece of evidence we have that we might not be alone. It is a ghost in the cosmic machine, a single data point that refuses to be explained away, a reminder that the universe's greatest mysteries often reveal themselves not with a declaration, but with a fleeting, unanswered question. The ghostly silence of the wow signal leaves us wondering who or what might be out there. But our own galaxy is home to celestial projectiles with no mystery about their origin, only their terrifying speed. Hypervelocity stars are exactly what they sound like: stellar cannonballs, entire suns hurtling through the Milky Way at speeds exceeding 1 million miles per hour. They are not born this way. They are the survivors of a cosmic slingshot, a gravitational catastrophe born in the heart of chaos. The most likely scenario for their creation is a dance with the supermassive black hole at the center of our galaxy, Sagittarius, a star. Picture a binary star system, two suns orbiting each other, drifting too close to the black hole's event horizon. The immense tidal forces can tear the pair apart. One star is captured, spiraling into a doomed orbit or being consumed entirely. The other, like a stone from a sling, is whipped around and flung outward with unimaginable kinetic energy, ejected from the galactic core at a significant fraction of the speed of light. The power required to accomplish this is almost beyond comprehension. A gravity well so deep it can take a star weighing billions of tons and launch it across the galaxy as if it were nothing more than a pebble. These are not subtle wanderers, they are stellar fugitives blazing a trail of intense radiation as they rip through the thin gas of interstellar space, their bow shocks glowing like cosmic headlights in the eternal night. The sheer violence of their birth is a constant, silent reminder of the forces at play in the dense, dark heart of our own home galaxy. While the odds are astronomically low, the concept of one of these stellar bullets passing near our solar system introduces a scenario of stellar-scale havoc. It would not need to collide with our sun to wreak absolute havoc. As it approached, its gravity would be the first destabilizing force, warping the delicate orbital balance of every planet, comet, and asteroid. The Oort cloud, that distant shell of icy bodies at the very edge of our system, would be stirred into a frenzy, potentially sending a storm of comets raining inward toward the planets. But the greater, more immediate terror would be radiation. A hypervelocity star would be a blazing beacon of intense ultraviolet and X-ray radiation, a stellar blowtorch pointed directly at our solar system. Long before any gravitational effects were felt, this radiation bath would begin stripping away planetary atmospheres, sterilizing surfaces, and fundamentally altering the chemistry of space around us. Earth's ozone layer would be obliterated in short order, leaving all life exposed to the lethal intensity of not one but two suns. The cosmic horror here is one of scale and indifference. Our entire existence, our history, our future, could be rewritten by a star that was simply in the wrong place at the wrong time billions of years ago. A random casualty of a black hole's lunch now on a collision course with our quiet corner of the galaxy. It is the ultimate bad neighbor, a visitor whose mere passage would be an extinction-level event. These stellar cannonballs are born from the violent heart of our galaxy. But what if the entire galaxy and everything in it is not what it seems? The holographic principle is one of the most radical ideas in modern physics, a theory that suggests our three-dimensional reality, with all its depth and solidity, might be nothing more than an incredibly convincing illusion. Think of a hologram on a credit card. That shimmering, three-dimensional image is not actually hovering above the plastic. It is encoded on a flat, two-dimensional surface. The holographic principle applies this same logic to the universe itself. It proposes that all the information needed to describe everything within a volume of space, every star, every planet, every thought in your head, could be perfectly encoded on the two-dimensional boundary that surrounds it like the surface of a sphere. In this view, our rich, textured world of mountains, oceans, and galaxies is not the fundamental reality. It is a projection, a cosmic movie being played for us, with the true data of existence stored on a distant, flat screen at the very edge of the observable universe. This is not science fiction, but a serious attempt to resolve deep contradictions between quantum mechanics and gravity, particularly when studying black holes. The mathematics suggests that the information swallowed by a black hole is not lost inside its singularity, but is somehow preserved on its two-dimensional event horizon, the point of no return. Extend this idea to its ultimate conclusion, and the entire cosmos could operate on the same principle. The implications are utterly terrifying to our sense of self. Your memories, your emotions, the feeling of wind on your skin, all of it would be data points on a cosmic hard drive we can never perceive. It means the solid ground beneath your feet is no more real than the image on a movie screen, a flawless simulation so perfect we are utterly convinced by it. This challenges the very core of human experience. Are we physical beings in a physical world, or are we merely shadows cast by information flickering on the walls of reality? If the holographic principle is true, then we are living inside the grandest illusion of all, a projection so vast and detailed that we mistake it for the only reality there is. If the holographic universe is a flawless illusion, then the landscapes of Saturn's moon Titan are a brutal, undeniable reality. This is not a world of rock and ice like our own moon. Titan is a place of profound and unsettling alienness, a looking-glass version of Earth where the rules of chemistry have been rewritten. It is the only other body in our solar system with stable liquid on its surface, but you would not want to swim in it. The rivers that carve valleys and the great lakes that span hundreds of miles are not filled with water. They are pools of liquid methane and ethane, hydrocarbons that exist as gases here on our warm planet. On Titan, the surface temperature is a soul-crushing 290 degrees below 0 Fahrenheit, cold enough to turn these compounds into a flowing, oily sea. Imagine standing on the shore of such a lake. The sky is a perpetual hazy orange, the thick nitrogen atmosphere blocking the distant sun. The ground under your feet is not soil but water ice as hard as granite. And before you, a dark, sluggish liquid the consistency of crude oil laps against a pebble shore made of frozen water. The very idea of a shoreline, something so familiar, becomes terrifying when the liquid is a poisonous, frigid soup. This environment is so hostile to life as we know it that it feels like a cosmic mockery of our own planet's features. Yet within that hostility lies another layer of dread. Scientists speculate that Titan's methane-based chemistry could, in theory, support a form of life utterly unlike our own. Instead of water-based cells, life might use liquid methane as its solvent. Instead of oxygen-based respiration, it might breathe hydrogen. Such organisms would be so fundamentally alien that we might not even recognize them as alive. They could be slow, cold, and strange beyond our wildest imagination, thriving in an environment that would instantly kill any Earth creature. Titan forces us to confront a chilling possibility. Life in the universe may not be rare, but it may be so bizarre, so adapted to conditions we find utterly lethal, that it is forever hidden in plain sight. The terror is not just in the landscape's hostility, but in the thought that we could be staring directly at a living world and see only a frozen, poisonous wasteland. The alien landscapes of Titan exist in a distant, frozen silence, but a far more immediate and man-made danger is spinning around our own planet at 17,000 miles per hour. This is the Kessler syndrome, a potential catastrophe of our own creation that could slam the door to the stars shut for centuries. Imagine a single collision in the crowded orbital highways above us. Perhaps two defunct satellites or a satellite and a piece of old rocket debris slam into each other. At orbital velocities, such an impact does not result in a gentle bump. It is a hypervelocity explosion, shattering both objects into thousands of jagged fragments, each piece now a high-speed projectile in its own right. This is where the nightmare begins. Those new pieces of shrapnel now orbiting Earth have their own paths. They cross the orbits of other satellites and space stations, dramatically increasing the probability of another collision. That second collision creates even more debris, which leads to more collisions. This triggers a runaway chain reaction, a cascading avalanche of destruction. Within a frighteningly short time, low Earth orbit could become a chaotic, swirling cloud of metallic shrapnel. A blizzard of razor-sharp fragments moving at bullet speeds 10 times faster than a rifle round. The consequences are immediate and total. Every satellite in that orbital shell, the ones that provide global communications, GPS navigation, weather forecasting, military surveillance, and scientific research, would be shredded. The International Space Station would be holed and evacuated if it could be reached at all. But the true, long-term terror is what comes next. That dense, self-sustaining debris field would become an impassable barrier. Any rocket trying to ascend through it to reach higher orbits or embark on interplanetary journeys would be riddled with impacts, likely destroyed before it could escape. We would be trapped. The dream of space exploration, of lunar bases, of missions to Mars would evaporate. We would be forced to watch from the ground as our robotic probes on other worlds fell silent, one by one, with no way to repair or replace them. Humanity would be caged on Earth, looking up at a shell of our own technological wreckage, a perpetual monument to our carelessness. The sky, once a symbol of limitless potential, would become a prison wall of spinning metal, locking us in with our problems and severing our connection to the cosmic ocean beyond. The prison wall of orbital debris is a cage of our own making, but out in the deep cosmos, nature forges cages of matter so dense they defy all reason. These are neutron stars, the undead corpses of massive stars that died not with a whimper, but in a supernova blast of unimaginable violence. When a star many times more massive than our Sun exhausts its fuel, its core collapses under its own weight. The force is so extreme that it crushes atoms themselves. Electrons are slammed into protons, merging to form neutrons. In less than a second, an object with more mass than our entire Sun is compressed into a perfect sphere barely 12 miles across, roughly the size of a major city. The density this creates is beyond human comprehension. A single sugar cube-sized fragment of neutron star material would weigh about 1 billion tons here on Earth. To put that in perspective, it would have the same mass as every human being on the planet combined, crushed into a speck you could balance on a spoon. This is matter in its most extreme, degenerate state, a crystalline lattice of pure neutrons packed so tightly there is literally no empty space left. But these city-sized monsters are not quiet tombs. They are spinning, magnetic zombies blazing with furious energy. Born from the chaotic spin of their progenitor star, they can rotate at speeds that make a blender blade look stationary. Some, known as pulsars, spin hundreds of times every second, sweeping beams of radiation across the galaxy like a cosmic lighthouse. If one of those beams were to sweep across our solar system, it would deliver a pulse of X-rays and gamma rays intense enough to sterilize a planet's surface. And then there is the magnetism. A neutron star's magnetic field can be quadrillions of times stronger than Earth's. This is not a gentle force. It is a distorting grip so powerful it can warp the very structure of atoms themselves, stretching them into long, thin needles. If you were to venture within a few thousand miles of such an object, the magnetic field would literally pull you apart at a molecular level long before gravity crushed you. These are not serene diamonds in the void. They are furious, hyper-dense dynamos, the ultimate consequence of a star's death, reminding us that in the universe, even a corpse can be more terrifyingly active than a living sun. That furious dynamo of a neutron star represents a known, if terrifying, physics. Yet the cosmos also crafts forms of haunting, unnatural beauty that defy our expectations. Drifting through the Milky Way, some 3,300 light-years from Earth, is a celestial object known as the Red Rectangle Nebula. Through our most powerful telescopes, it does not appear as a cloud or a sphere, but as a stark, geometric riddle. At its heart, glowing with a deep crimson light, is a near-perfect X-shaped structure. This is not an artist's rendering or a trick of the light. It is a real, physical formation of gas and dust, with two bright, intersecting diagonal bars creating a shape of startling symmetry against the black velvet of space. The central star is a binary system, two elderly stars locked in a close orbital dance. Astronomers believe that as these stars aged, they began shedding their outer layers in dense, equatorial outflows, like spinning tops flinging off material from their middles. The prevailing theory suggests that a thick disk of dust surrounds the binary, and this disk is constricting those outflows, funneling them into two opposing cones above and below the plane. From our vantage point, looking almost directly at the edge of this dust disk, those two cone shapes project the illusion of an X. The science offers a plausible mechanism, but it does nothing to ease the eerie feeling it evokes. The precision of the geometry is unnerving. Nature tends toward chaos, toward spirals and blobs and irregular clouds. The red rectangle presents something that looks meticulously crafted, almost like a cosmic brand or a beacon deliberately formed. It stands as a profound reminder that the universe, in its infinite complexity, can spontaneously generate structures of such ordered, architectural perfection that they appear artificial to our pattern-seeking minds. This nebula whispers that the line between natural phenomenon and intelligently designed artifact can be breathtakingly thin, forcing us to question every assumption about what is possible in the silent, creative dark. The geometric perfection of the red rectangle nebula feels like a cosmic whisper, but if you could press your ear against the void, you would hear something far more unsettling. The common belief is that space is utterly, perfectly silent. This is only half true. The vacuum between stars is so empty that sound waves, as we know them, cannot travel. There is no air to carry a shout or an explosion, but space is not a true nothingness. It contains a very thin soup of gas and dust, a medium so tenuous it is almost a phantom. In regions where this soup is slightly denser, like within vast nebulas or the outer atmospheres of stars, incredibly low-frequency vibrations can, in fact, propagate. These are not sounds any human ear could ever hear, but they are vibrations in a medium, a ghost of the physics we understand. The true auditory horror, however, comes from what we can detect by other means. Scientists use instruments like radio telescopes to collect the electromagnetic emissions from celestial objects, the radio waves, the plasma vibrations, the magnetic pulses. These signals are not sound, but we can translate them, shift their frequencies down into the range of human hearing. This process, called sonification, gives the cosmos a voice. And what a terrifying voice it is. The radio waves from Jupiter's ferocious magnetic field, when converted, become unearthly whistles and pops, like a demented short-wave radio broadcast from a storm the size of a planet. The plasma waves trapped in Saturn's rings sound like a chorus of robotic insects, a constant, chittering static, but perhaps the most haunting are the sounds of dying stars. The vibrations from a pulsar, the rapidly spinning corpse of a supernova, can be rendered as a rapid mechanical ticking, a relentless metronome in the dark. Other stellar emissions become long, drawn-out moans or piercing, digital-sounding screams. These are not the harmonious music of the spheres imagined by ancient philosophers. This is the soundtrack of a violent, chaotic, and deeply alien universe. Listening to these sounds creates a profound sense of dread because they strip away the beautiful, silent visuals of astronomy and replace them with something raw and emotional. We are hearing the universe not as a painting but as a machine, a vast, screaming engine of plasma and magnetism where nothing is still and nothing is quiet. It is the noise of pure physics, and it sounds like loneliness and fury given form. That cosmic noise of screaming plasma and ticking pulsars comes from the violence of active stars, but at the very edge of our sun's influence lies a place of perfect, frozen silence. This is the Oort cloud, a theoretical shell of icy debris that forms the true outer boundary of our solar system. It is not a belt like the Kuiper belt past Neptune. Think of it instead as a vast spherical cloud, a shell of frozen leftovers from the solar system's violent birth 4.6 billion years ago. Its inner edge is thought to begin about 2,000 times farther from the Sun than Earth, and its outer fringe may stretch a light year or more into the interstellar void, halfway to the next star. Within this immense dark volume, billions, perhaps trillions, of mountain-sized chunks of ice and rock drift in slow, silent orbits. They are not planets. They are primordial planetesimals, the unused building blocks of worlds, never coalescing into anything larger, preserved in a deep freeze that has lasted since the dawn of our sun. This distant cloud is the source of our most dramatic celestial visitors, the long-period comets. These are the comets with orbits that take thousands, even millions of years to complete. Their journeys begin when a chance gravitational nudge, perhaps from a passing star or the subtle tide of the galaxy itself, dislodges one of these icy bodies from its slumber. It then begins a fall that lasts millennia, plunging inward toward the warmth of the inner solar system. As it approaches the sun, the ice vaporizes, creating the glorious, streaming tail that has awed and terrified humans for all of history. Every brilliant comet you have ever seen in the night sky is in essence a corpse from this distant graveyard, briefly resurrected by solar fire before it either disintegrates or is flung back into the dark. The Oort cloud is more than just a comet factory. It is a frozen borderland, a reminder of the chaotic construction site our neighborhood once was, and a reservoir of materials so ancient it holds the uncontaminated recipe of the early solar system. It is also a hauntingly empty place. The objects within it are so far apart that a traveler passing through would likely never see one, drifting in a perpetual night where the sun is just a particularly bright star, offering no warmth, no light, only a reminder of the distant heart of a system it barely feels. This vast, dark shell is the final monument to our system's birth, a silent, icy sentinel watching over all we know. That silent, frozen graveyard of the Oort cloud exists in a realm governed by the physics we think we understand, but at the smallest scales of existence, the universe operates on a rulebook that seems to defy all logic and distance. This is the baffling, beautiful, and terrifying phenomenon of quantum entanglement, a concept so strange that even Albert Einstein, who helped lay its foundations, famously dismissed it as spooky action at a distance. To understand why it spooked him, picture this. Scientists can create a pair of particles like photons or electrons in such a way that their properties become inextricably linked or entangled. They are no longer independent entities, but two halves of a single quantum system. You can then separate these particles, sending them flying in opposite directions across a lab, across a city, or even across the galaxy. Here is where reality seems to break. If you measure a specific property of one particle, say, its spin or polarization, the other particle, instantly and without any signal passing between them, assumes the corresponding correlated state. This happens faster than light could ever travel between them. It is as if you flipped a coin in New York, and the very moment it landed heads, a twin coin in Tokyo without any communication knew to land tails. This instantaneous connection appears to violate the cosmic speed limit set by the theory of relativity, the law that nothing can travel faster than light. Einstein believed this meant our understanding of quantum mechanics was incomplete, that there must be some hidden variables, some deeper layer of reality we had not yet discovered that predetermined the particle states. Yet, decades of meticulous experiments have consistently confirmed that entanglement is real. The spooky action is not a flaw in the theory, it is a feature of the universe. The implications are profoundly unsettling. It challenges our most basic intuition about locality, the idea that objects are only influenced by their immediate surroundings. Entanglement suggests that space itself, the vast emptiness that separates stars and galaxies, might be an illusion when it comes to certain quantum connections. Two particles can be light years apart, yet remain a single, unified entity. This hints at a universe that is deeply, fundamentally interconnected in ways we cannot perceive, a cosmic web where separation is a trick of perspective. It forces us to question the very nature of reality. Do particles have definite properties before we measure them, or do those properties only snap into existence at the moment of observation, instantly defining their entangled partner across the void? The universe, it seems, does not play by the rules of cause and effect as we experience them in our macroscopic world. It operates on a layer of reality where everything is potentially linked to everything else. a whispering network of instantaneous influence hidden beneath the surface of the solid, separate world we think we know. The universe's hidden quantum whispers hint at a reality far stranger than we can perceive. But what if the strangeness is not just hidden but perfectly mirrored? Our final terrifying fact takes us to the bleeding edge of theoretical physics, to a concept that feels ripped from the pages of the most mind-bending science fiction. Some physicists speculate that our universe might have a twin, a mirror cosmos born in the same instant as our own, where every single physical law is perfectly inverted. This is the idea of a CPT symmetry universe. The letters stand for charge, parity, and time. In this mirror realm, every particle's electrical charge will be flipped, positives become negatives. Parity means spatial dimensions are mirrored, like looking into a perfect looking glass where left is right and right is left. But it is the final letter, T for time, that delivers the true existential shock. In this mirrored twin, time itself could be flowing backwards relative to our own. From our perspective, that universe's history is its future, and its future is its past. Imagine a reality where shattered glasses reassemble on the floor and leap back onto tables, where light is absorbed into stars instead of radiating from them, and where lives are lived from grave to cradle. The brain struggles to even frame what such a cosmos would be like to experience from within. The terrifying beauty of this theory is that it emerges not from fantasy, but from the cold, hard mathematics of our most successful physical models. The equations suggest that for our universe to exist with the precise balance it has, a perfect mirror might be a necessary counterpart, a cosmic counterweight. This mirror universe would be forever separated from us, unable to interact, a ghostly echo of our own existence playing out in reverse on the other side of creation's birth. The profound dread comes not from the possibility of invasion, but from the sheer, lonely scale of existence it implies. Our entire cosmic story, with all its drama and struggle, might be just one half of a coin, the other face of which is a reality where every cause and effect we hold sacred runs in perfect, inverted parallel. It means that for every action here, there is an equal and opposite reaction, not just in force, but in the very fabric of time and identity, somewhere we can never see, never touch, and never truly comprehend. Our entire cosmic story might be just one side of a mirrored coin, but here in our own reality, a colossal clock is ticking. Our solar system is not stationary within the Milky Way. We are on a grand, sweeping orbit around the galactic center, a journey that takes between 225 and 250 million years to complete just one single circuit. Astronomers call this immense time span a galactic year. Picture the history of our planet measured not in Earth years, but in these slow galactic heartbeats. Complex life on Earth has existed for roughly the last one galactic year. The dinosaurs rose and fell within about half of one orbit. The entire span of human civilization, from the first cities to this very moment, is a blink so brief it does not even register on this scale. This orbit is not a serene cruise through empty space. Our sun, with all its planets in tow, is moving through a galaxy with structure, specifically through its spiral arms. These arms are not solid, but waves of higher density where gas, dust, and young, massive stars are packed more tightly together. As our solar system journeys around the galaxy, it periodically enters and exits these dense spiral arms. And here lies a terrifying theory that ties the fate of life on Earth to the rhythm of the galaxy itself. When we pass through a spiral arm, the environment around us becomes far more dangerous. The density of stars increases, raising the probability of a close stellar encounter that could perturb the Oort cloud and send comets raining inward. More critically, the spiral arms are where short-lived massive stars are born. These stars live fast and die young in spectacular supernova explosions. Passing through an arm statistically increases our proximity to these cosmic bombs. A nearby supernova, as we have discussed, could bathe our planet in lethal radiation, stripping the ozone layer and triggering a mass extinction. Some scientists have looked at the fossil record and found a chilling, if controversial, pattern. Several of Earth's great mass extinctions appear to occur with a rough periodicity of about 26 to 30 million years. This time frame intriguingly matches estimates for how often our solar system might oscillate through the galaxy's dense midplane or pass through a spiral arm. The implication is profound and deeply unsettling. The rise and fall of species, the dominance of the dinosaurs and their sudden erasure, the survival and evolution of mammals, might not be purely random events driven by earthly geology or isolated asteroid strikes. They could be preordained by our place in the galaxy, a scheduled catastrophe written into our cosmic address. We are passengers on a planet that is itself a passenger on a star, and all of us are moving through a galactic environment that changes from relatively safe to lethally hazardous on a timetable of tens of millions of years. Our current position, we are on the inner edge of a minor spiral arm called the Orion Spur, having recently passed through a denser region. We are, according to this galactic clock, in a relatively quieter neighborhood for now. But the clock keeps turning. In another few tens of millions of years, our solar system will once again drift into a denser, more violent spiral arm, and the cosmic conditions for another great filter may align. It suggests that even if a civilization like ours arises, its long-term survival is not just a matter of technological wisdom or planetary stewardship. It is a matter of celestial timing, of being born during the right chapter of the galactic year. This galactic clock that measures our fate in 100 million year cycles also forged the very atoms that give us life. Every element in your body heavier than hydrogen and helium was not born in the calm nursery of the early universe. It was forged in the nuclear furnaces of stars and scattered across the cosmos by their violent deaths. The oxygen you breathe, the carbon that forms the backbone of your DNA, the nitrogen in your cells, and the iron that carries life-giving oxygen in your blood, all of these were created under immense pressure and temperature inside a star that no longer exists. This is the beautiful, terrifying poetry of our existence. We are not just observers of the cosmos. We are its walking, talking archives. The calcium in your bones was likely forged in the last, desperate moments of a massive star's life, just before it tore itself apart in a supernova explosion of unimaginable fury. That cataclysm, capable of sterilizing planets light years away, is also the very reason you have a skeleton. The gold in a wedding ring or the uranium in a power plant were likely created in the even more extreme violence of colliding neutron stars, events that ripple the fabric of space-time itself. So when you look up at the night sky, you are not looking at distant, unrelated points of light. You are looking at your distant ancestors and your atomic kin. You are looking at the factories that built you. This connection is profound, but it is also grim. Your existence is predicated on a chain of stellar genocide. For you to be here, countless stars had to live out their lives and die in spectacular ruin, seeding the galaxy with the heavy elements that would one day coalesce into a planet and eventually into you. We are the universe's way of knowing itself, but we are also its ghosts assembled from the ashes of countless ancient infernos. Our heritage is one of catastrophic beauty, a reminder that life is not a separate phenomenon from the chaos of the cosmos. It is the cosmos, temporarily arranged into a form that can wonder about its own violent and glorious origins. This journey through the cosmos has revealed a universe far stranger and more hostile than our night sky suggests. From the silent, bodily horror of the vacuum to the universe's inevitable frozen death, we have charted a landscape of invisible forces, random violence, and existential dread. We are living on a fragile world in a shooting gallery under the gaze of a star that will one day consume us within a galaxy being pulled toward an unseen monster. Our reality may be a holographic projection, Our atoms are the ashes of dead stars, and our future may be dictated by a galactic clock we cannot stop. Yet here we are. The profound terror of these facts is matched only by the profound courage required to seek them out, to stare into that abyss, to measure the pull of dark matter, to listen for whispers in the cosmic static. This is what humanity does. We are a species born from stellar cataclysms, now using the very minds that stardust built to unravel the terrifying and beautiful machinery of our existence. In a universe designed to humble and frighten us, our curiosity itself is an act of defiance. So tell us, which of these 30 truths chilled you to your core? Was it the great filter, the rogue black hole, or the ticking clock of our dying sun? Let us know in the comments below. If you are ready to confront more mysteries hidden in the dark, make sure to subscribe. Our exploration of the cosmos has only just begun.